But today we're switching over to Microsoft Server with Hyper-V role. So today we're going to look at installing and configuring the Hyper-V role. There's a couple of different ways of installing it, obviously, but in our worksheet there is the graphical user interface is the main one we use, but obviously PowerShell, and many other ways are possible as well. So today we're going to give you an overview of the Hyper-V role. I think most of you would know what Hyper-V is already, and most of you should realize that it's a additional component of Microsoft Server. So it's actually comes with the Microsoft Server operating system. Doesn't matter which version, it comes with it. Okay. But general practice is that you don't make your Hyper-V server anything else besides a Hyper-V server. So it shouldn't be a domain controller plus Hyper-V, for example. Shouldn't be a file server plus Hyper-V. Basically, Hyper-V is just Hyper-V. And the ideal Hyper-V server is not a server, Microsoft server, with the graphical user interface installed. So if you remember back into your Cert 4 days, that we can install Microsoft server with or without the desktop experience. So there's the server core, there's a full desktop experience, and there's Nano server, which is even smaller than the server core. Ideally, a Hyper-V server would be that Nano server. Probably somewhere in the middle is that server core, and probably the way we're doing it in our class, which is to make it easy for you guys as students, is to make it a full desktop experience. Is probably the worst way. Probably not the in practice when you see a Hyper-V host, you'll never see it set up like this. So that's just a disclaimer that I'm going to say up front, even though that's the way we're doing it. We're doing it because we need to learn it. And to learn it, it's easier to troubleshoot and fix if it's got the graphical user interface. So today we're going to be installing the Hyper-V role. We're going to be managing Hyper-V. We're going to configure some of the Hyper-V settings, and then we're going to look at Hyper-V host storage and networking. So let's get straight into it. So the server platform that provides Hyper-V is Microsoft Server, and it includes the Hyper-V role and many other roles. There's the graphical user interface and command line management, but obviously, like I mentioned just before, ideally on a Hyper-V host, it would be the server core or Nano server. Even though those do not have a desktop environment, we can still remote administer those by using our graphical user interfaces. For example, we could install the Hyper-V Manager software, not the Hyper-V hypervisor or virtualization platform, but just the management tools on another device or computer, and then connect it to our Hyper-V roles, and then administer them remotely anyway. So the Hyper-V licensing is per processor and includes virtualization rights. So like I said in Cert 4, when you buy any version of Microsoft Server, for example, standard, you get the hypervisor Hyper-V role, which then includes, for standard that is, 2 virtual machines, each with the Windows Server operating system fully licensed. So what does that mean? You pay for 1 licensing, you get 1 physical server, and then you can get 2 virtualized server, which are Windows Server. So obviously, if you need more than 2 for a standard edition, then you start paying for that next license, and so forth. But with the Enterprise Edition, if you buy the Enterprise Edition Hyper-V, you get unlimited virtual machines with each Windows Server operating system. What does that actually mean? It means that if you buy an Enterprise version license, you can install 1 physical machine. Then on that 1 physical machine, you can create as many virtual machines with the Windows Server operating system as you like, and they will all be fully licensed. Obviously, what is the limitation? So the first thing you see in the dot points is the fact that it's licensed per processor. Okay, so if you remember, this Microsoft Server is licensed, depends on how many processors you have, and especially important on the Hyper-V because obviously the more processors you have, the more work you can do, and the more virtual machines it can virtualize. So therefore, uh, you know, if you have the enterprise edition with like a quad processor, and each one has a 4 cores, then with hyperthreading 8 cores. So that makes it 32 processors. That's going to cost certainly that's going to cost a lot more than if you get the enterprise edition for for a computer with one processor with 4 cores, okay, and no hyperthreading. So that's going to cost a lot more because it can do a lot more. So don't worry, Microsoft knows how to get their money, and they will get their money in that way. But still, if you think about it, like probably if you look at the assignment, like I said last week when we were talking about the assignment, when you're assessing the virtualization platforms, the licensing and how much costs you is it's a very important consideration as well. Because if my company had an open sourced philosophy and all our servers were Linux operating system, then getting this Hyper-V platform, yeah, it's fine. I can still virtualize Linux virtual machines, but the thing is, I'm not getting any advantage from this licensing, from this free licensing. But if I got the vSphere platform, then there's no licensing included for any virtual machines. So those Linux ones would cost the same anyway. You just pay for the virtualization platform. Whereas if I had a Microsoft environment, like for example your assignment suggests you do, so you have all Microsoft servers, physical servers, and you have just that one Linux server, which was, I can't remember, I think it was the web server or the database server, can't remember which one. If that was the case, if you chose Microsoft Hyper-V, then all of those virtual machines which were Microsoft could potentially use some of these free licenses that you're getting included. Whereas if you're using the vSphere, besides paying for vSphere, you also need to be paying for the licensing per virtual machine anyway. There's also another type of server, which is just the Hyper-V server. And this is a special license, special installation. It includes only the Hyper-V role. It's only command line. It's if only locally managed, but you can obviously manage graphical user interface remotely. And this is free from Microsoft. That's probably not that's probably not something you hear often, free from Microsoft. But this particular version is free, and virtual machines must be licensed separately after that. But this is in direct competition to ESXi. So if you remember, ESXi by itself, without vSphere, is free. It's only the vSphere license that makes that ESXi much more powerful, and that becomes licensed. So this Hyper-V is a direct competition. Windows client operating system. So we all know that Windows 10, 11, all include Hyper-V on those operating systems as well. So client Hyper-V does not include any of the server level features such as high availability or live migration. So those are equivalent to your VMware workstation, if you like. You're installing on the workstation computer and you're doing local virtualization only. And it's not for replacing physical servers in the physical server room. So if we look at this is obviously a little bit outdated, and as you expect from these type of slides, they get outdated very quickly. So you can see that we're talking about 2022 and 2019, so they're not outdated just yet. But if I was teaching this next year after that, these will become outdated. So let's have a look at this. So if we look at the Hyper-V and virtual machine scalability. Scalability means the ability to expand and get bigger or provide more capacity without redesign. So the system can support logical processors 512. This is the upper limits, by the way. This is all dependent on how many physical processors or processor cores you've got in your system as well. Just because it can support 512 as a theoretical maximum doesn't mean that you have the uh, physical capabilities of having 512 cores. What does that mean? Really, 512 cores means that you would have some system where you have however many physical CPUs, how many cores on each of those physical CPUs, and then combined that with hyperthreading, that's a lot of CPU cores. And I don't think any server you can buy in practice will be able to give you that much. So this is a design maximum, which means that it's in the future when they have better and better hardware, you can still accommodate that growth. The amount of memory, again, these are the upper limits. Okay, so on 2022, which is the latest version of server, you can have 48 terabytes of RAM. Again, probably couldn't find a physical system that could accommodate 48 terabytes of RAM, but this is the upper limits. And then the virtual processors is 124. So this is the virtualized uh, virtual machines, the processor inside the virtual machines. Oops, sorry. So virtual machines, virtual processors per virtual machine, you can have 64 for generation 1, 240 for generation 2, and we'll discuss what generation 1 and 2 means in a later slide or session. And the memory per virtual machine is 1 terabyte, 12 terabyte for generation 1 and 2. Again, these are upper limits. How many virtual machines you can run per server? Well, 1024 virtual machines. But again, this is the upper limit and depends on what hardware you've got. Number of virtual disk size, 64 terabytes. Failover nodes. Oops. Failover nodes. So that's how many members in a cluster is 64. And I think there was something that's right at the bottom I couldn't see. Running virtual machines per cluster, it can support 8,000. So that didn't fit in the window properly. Considerations for disk and storage. So remember our idea of that shared storage. So from vSphere, it's the same. Okay, so all those things we spoke about having that shared storage and having that shared storage supporting that live migration or vMotion, supporting that high availability, all those kind of things, they are the same types of things we need to consider for Hyper-V as well. So it's not totally different. It's almost like there's a one-for-one comparison between Hyper-V and vSphere. It's just that they might be called different things. So Hyper-V hosts can use DAS, which is a different way of saying direct attached storage. So that's basically your internal hard drives, local hard drives, your USB hard drives. Nothing too difficult there. It can use SANs, and SANs are those fiber channel, the fiber channel over Ethernet, iSCSI that we've been talking about. And it can also support NAS. Okay, unlike vSphere, which uses the NFS for NAS, in this case, we can use SMB3. So that's Samba, or sorry, not Samba. That's the network Windows network sharing, but it's a share for applications where you go to create it on your server. Instead of just sharing a folder, you need to create it as a share for applications. It's done in a special way. So when you create a share for applications, it's a SMB version 3, which includes the features required for running virtual machines often. So virtual machines require storage for the virtual hard drives, the configuration files, the checkpoints, and the save state. So nothing new here for us. We're so familiar with this. Just a couple of different names. So virtual hard disk files, configuration files, they're easy to understand. But checkpoints is another word for snapshots. So VMware uses the term snapshots. Microsoft uses checkpoints, means the same thing. Save states is easy to understand as well. So when you pause a virtual machine, the pause state is that saved state. Considerations for networking. So same considerations we had for vSphere. We should have multiple NICs, okay, separating the different types of networks. We should have redundancy so that we can have failover. and to improve the throughput and bandwidth. So Hyper-V should have multiple network cards, at least one dedicated for the Hyper-V management, at least one NIC dedicated for the virtual machine traffic, at least two NICs dedicated for the storage, to the shared storage, and at least a dedicated NIC for failover clustering, if you do have failover clustering, and at least one network interface card for live migration, which is equivalent to the vMotion. We should be using the fast NICs, so where possible. And there's this thing called NIC teaming, which essentially basically is our load balancing between extra two or more network interface cards. And it's for redundancy and also load balancing. Considerations for high availability. So Hyper-V host should, Hyper-V host-based failover cluster. So virtual machines are highly available. So if you don't know what failover cluster is, just think of our high availability. So remember how where you've got multiple hosts, and if one of the hosts fails, the virtual machine running on that host gets restarted on a different host. This failover clustering is basically equivalent to that. There's virtual machine-based failover clustering as well. So this is cluster roles in the virtual machine are highly available. So what does that mean? That's basically similar to that high availability where they're monitoring the virtual machines with their heartbeat. If you remember, the virtual machine heartbeat through the VMware tools. So if the virtual machine itself is not running properly, then it's restarted. And that's equivalent to that. There's also the virtual machine based network load balancing, or NLB. And these are highly available and scale out web based applications. So this is actually a little bit different. This is where it's using the Microsoft network load balancing. So it's part of the virtual machine operating system. So even though it's saying this here, you can still implement virtual machine based network load balancing, even if they were being virtualized on a vSphere platform. Then there's application specific clustering. So for example, this is the program or the applications installed inside the virtual machine, such as, let's say, Oracle database. So again, this is not specific to VMware or Hyper-V. This is the clustering that occurs between the virtual machines that has the same, let's say, Oracle database spread across multiple virtual machines. So changes to the host. So once you install Hyper-V, there's obviously things added, things turned on, and things appear that wasn't there before. So the things you could check is that in Server Manager, we can actually install Windows feature, or we can actually, so we can install Hyper-V, should I say, in Server Manager with the install feature commandlet in PowerShell, or using the DISM-XE program. It requires a restart after you install. So it's the same as Windows 10 and 11 if you've done that before. And then the hypervisor service is started automatically. And these are some of the services that gets added to your server once you actually install Hyper-V. So there's the guest shutdown service, which basically means that we can shut down the guests, which are virtual machines. Instead of actually just powering them off, we can just initiate a shutdown. So the heartbeat, okay, if you remember, we use heartbeats to monitor the health or the activity of virtual machines and their hosts. Then we've got the Hyper-V remote desktop virtualization service, which basically allows us to remote administer the Hyper-V. The time synchronization service, as we know that the virtual machines that are run on the host will synchronize their time normally with the host. We've got the Hyper-V Virtual Machine Manager, which is actually the equivalent of our vSphere, but you'll see that in our subjects, we will not be looking at the Virtual Machine Manager because that's actually not enough time in the subject, and also at a level that's probably wouldn't be the next level up. And there's also the volume shadow copy. Besides that, we have the Hyper-V management tools, which is the Hyper-V Manager. These additional services, we've got additional performance counters so we can monitor the performance. we've got the additional logs installed into our event viewer so we can view the logs from. And then you'll see that there's a Hyper-V administrators group created. And there's also the firewall rules are created to allow for communication with the Hyper-V. So this is an older version of Hyper-V. I think this is Server 2012 version, but essentially it looks the same. Just different look and feel, but essentially the components are the same. So if we look at this, this is a Hyper-V manager tool, which is the tool we'll use to manage the virtual machines and Hyper-V itself. So with the way we're doing Hyper-V, we're treating the Hyper-Vs as individuals, but we can add the different hosts into the same view by connecting it remotely. So this is what I'm talking about by we can install this Hyper-V manager. It doesn't even have to be on the Hyper-V server. It could be on your Windows 10, but we can connect to the Hyper-V servers remotely and still manage it like this, assuming you've got the right credentials, of course. So these are the Hyper-V servers on the left pane, but this is a typical Windows or Microsoft interface. We've got 3 panes, left, middle, and right. So on the left, you have the nodes. On the middle, you have the current selected object and then some information about it. On the right, there's usually actions you can perform. So here we've got server 1 selected, which is a Hyper-V server. And then when we select that, the contents of server 1, which is all the virtual machines in here, are displayed in the center. And then we've selected here the London DC, which I think is the domain controller for the London site. That's what scenario is here. And we can see that's running. And the CPU usage is 25%. It's using about 2 gigs of RAM, and it's been up for 8 hours. And if we select that on the bottom part, you see the checkpoints, which are basically the snapshots. And basically you can see that each one of these nodes or each one of these things is a different snapshot and you're here. So basically very similar to our snapshot manager, and then you can see your relative position to all the snapshots. Over here you can have the Hyper-V settings. So these are actions you can configure the Hyper-V server itself, and down here are the actions you can perform on the selected virtual machine. But this will become more obvious when you start using it. Adding the Hyper-V Manager console. So like I said, you don't have to install Hyper-V. You could just add the Hyper-V Management console if you're just using it to manage other Hyper-Vs. So it's used for configuring Hyper-V. It's also added on the Hyper-V server, obviously, especially if it's a graphical, a desktop experience version. If adding the Hyper-V role by using the server manager, the Hyper-V Manager's console is automatically added. The Hyper-V management tool is a feature you must enable. So on Windows Server, you can add the feature, and on Windows 8, Windows 8, not 10, 11, you can turn on the features like, let me see if I can open up the apps. So if you look at this is my physical computer. So this is actually my laptop computer. So it's a Windows 10. If I go to apps and features, and then we can look at what's installed, obviously. But if we go to optional features, sorry, this is sorry, I don't usually use it this way. I use control panel. I'm not as familiar with that, but if you turn on Windows features, you'll see that there's a Hyper-V. Obviously, you can install the Hyper-V platform, but if you just want to use it to manage other Hyper-Vs, you would just install the Hyper-V management tools, which then means from my Windows 10, and as the network administrator or just the Hyper-V administrator or whatever role I have, I can actually use this tool to connect to the Hyper-V servers and then manage them. I'll cancel that. Close these. So we can also install the RSAT, which is the remote system administration terminal, and turn on the Windows feature. That's a Windows 7, so it's a bit old now. So, but if Hyper-V Manager console cannot run on the device, we can also use the remote desktop to manage the server directly. Like I mentioned, anything you can do with the graphical user interface, you can do with PowerShell. And here's some PowerShell commandlets. I'm not going to go through all of them, but like I said, to be honest, we're learning Hyper-V. You you generally don't start using the PowerShell management aspect of it until you fully understand how to use Hyper-V. And the easiest way to learn Hyper-V is through the graphical interface. And then once you know that well enough, you can actually learn the PowerShell commandlets and the automation that goes with it. And saying that, so we can also use the PowerShell remote PowerShell to actually execute PowerShell commands on the Hyper-V server or even inside the virtual machines of the Hyper-V on the Hyper-V server. Can be a work group member. So like if you're wondering what was he talking about? So if you remember in Microsoft, you can have work groups or you can have domains. Work groups is where there's no domain and everyone's just sort of peer-to-peer networking. And that's fine for a small network. Let's say for a small accounting firm with 5 users, you might just want to have a Hyper-V server that virtualizes some of the services that you have. You have one physical machine, you have a Hyper-V server, and on there we have a virtual file server, we have a DNS server, we have whatever server. And that's fine for those situations. But if you're not a member of the domain, you have more than one Hyper-V host, then management of it is very hard. Probably only can manage one at a time, really. But if you're at all wanting to do more than one Hyper-V and use any of the more advanced features, then domain membership is pretty much a requirement. To enable remote management in a workgroup, you have to enable the Hyper-V firewall rules, which is for server core only. Create a local user with the same username and password. Add the local user to the Hyper-V administrator group. Grant administrative privileges to the local remotely to the local user, and then connect to the Hyper-V through the Hyper-V console and use the HV remote to simplify configuration. So you can see that's a nightmare. That's a nightmare. There's a lot of work. That's equivalent to the nightmare that is a peer-to-peer networking just for creating user accounts across multiple machines. So it's probably just as hard, just as many problems. And I can tell you now, like if you change the username or the password, and if you have multiple Hyper-V servers, then you have to change it all the time on all of the machines. So even though you can run it as a workgroup computer, it's probably recommended that you do it in a domain. There's also a Hyper-V best practice analyzer. So if you don't know about best practice analyzer, Microsoft supplies a lot of best practice analyzers or BPAs for various services. And basically what it does is it actually has these rules that is what they recommend you do. And basically it's a guidelines for typical deployment, and the Hyper-V BPA includes 110 rules, including Hyper-V should be the only role enabled. Server core is the recommended Hyper-V server. It's a domain membership is recommended. So it will check all of those things for you, and then it will give you a report on what you're doing, what you're not doing right. The BPA is available in Server Manager and Windows PowerShell, and you can scan one or multiple roles locally or remotely, and then you can filter the scan and you see, oh, which compliance. So compliance means, am I obeying those 110 rules? So obviously, if you are, you might just get information. If you're not, but it's not a really important rule, you might get a warning. But if it's a really critical thing, like it's going to cause security issues, you might get an error. And with that, hopefully it guides you to fixing up those requirements. So the Hyper-V security model. So authorized managers control the Hyper-V security. It's challenging to use. It's not suitable for complex rules, and it's deprecated. So really, we shouldn't be talking about that much. But if you do see it somewhere, the authorization manager is something that existed. But in Server 2012 and newer, simple authorization is used. So Hyper-V administrators local and domain groups are empty by default. Members have full access to the Hyper-V, and Hyper-V administrator groups is incorporated into the authorization manager. So if we look at this is just talking about the roles and groups. Let's look at the settings. So, this picture is zoomed in a little bit too much, but basically these are some settings you can configure. Where are the virtual hard disks stored? So obviously we have virtual machines. Where are they stored? The hard disk and the virtual machine configuration files. We know that in VMware they're the VMDK files and VMX files, but they don't have to be stored in the same location, as you can see by these two settings. So obviously it's virtual machine management. It's something we all know. We should obviously include all our virtual machines in a single folder, and we try to keep the configuration files and the virtual hard disks together where possible. This is the GPU. We don't usually do too much about that because most of the time it's not a very pertinent requirement that the GPU, physical GPUs for the virtual machines, mostly is not graphical intensive. NUMA, we'll talk more about NUMA in the future, but that's a non-uniform memory allocation. So it's to do with memory allocation. The live migration, if you remember, is it's equivalent to our vMotion in vSphere. So basically, this is the live migration settings. The storage migration is equivalent to that storage vMotion, and again, these are settings to do with that. Enhanced session mode policies. So basically, this is stuff that helps you interact with virtual machines better. There's a replication configuration. So this is where we can actually replicate virtual machines from one site to another site, which actually is great for disaster recovery. So these are user, which basically these are some of the hotkeys. Like we still have to click into the virtual machines, but how do we get out of it? These are similar to the Control Alt. What do we do? Control C, I think, releases our mouse in the VMware. Or something like that. I can't remember off the top of my head. And enhanced session mode is actually enhances the user experience, a bit like what features of VMware tools are turned on and so forth. And the reset checkbox just turns everything off. So like I said, NUMA, what's a non-uniform memory allocation, enables hosts to scale up CPU and memory. It partitions CPU and memory into NUMA nodes, and then allocation and latency depends on the relative CPU locations. The Hyper-V presents the NUMA topology to the virtual machines. The guest operating systems can make decisions on how to use the resources, but you can actually minimize cross-node memory access. What does that last point mean? It means that the virtual machines, the various virtual machines won't access other virtual machines' memory. NUMA spanning enables the host, which is the Hyper-V, which is enabled at the Hyper-V level. Virtual NUMA topology can be configured at the virtual machine level, and by default, virtual NUMA aligns with physical NUMA. So how much do we need to know about this? Not much to pass our subject. But basically, this is a memory allocation method in Hyper-V. So we're talking about a lot of things today, and obviously some of these things will be pertinent, but some of these things are just good to know, like we always do. So what is Remote FX? It provides a remote desktop experience that may be equivalent to a physical desktop environment. So it just basically makes everything look better and run better and look smoother and so forth. And they obviously means better graphics, second level address translation, and RD virtualization service role are required. The Remote FX 3D video adapter, virtual machine, virtual hardware, and some of these include Remote FX for WANs. So, what if you're managing the virtual machines across a WAN, which is a slow link? What if you can have adaptive graphics? You can use Remote FX media streaming. You can use Remote FX multi-touch and USB redirection. So basically, the multi-touch basically allows you to use a touchscreen device and then interact with the virtual machine through your touchscreen device with the touch. And USB redirection is similar to what we can do with the USB on our virtual machines in the VMware workstation, which is to redirect our physical devices onto the virtual machine. Enhanced session mode, so the remote desktop over VM bus, it gives you the full remote desktop capabilities such as shared clipboard, printers, USB device redirection, and folder redirection. This is similar to what we can do with our VMware tools on VMware workstation, obviously. This is enhanced session mode is either enhanced at the Hyper-V level, and the guest operating system needs to be later than these ones. So here's a bit of flowchart or how it works, but I'm not going to go through this with you because, like I said, do we need to know this for our passing this assignment or the subject? Probably not. This is just good to know if things go wrong, but basically that's how it interacts with each other and then the Hyper-V and the virtual machines. So basically it enhances the session mode with the remote desktop service. What are resource pools? So again, we're talking about a lot of things, but some of these things will come up later, but right now we're sort of mentioning them. So resource pools are similar to the idea of resource pools we mentioned in the vSphere. Resource pools are logical containers. They're a layer of abstraction between virtual machine and the hardware. Virtual machines are configured to use the pool, and virtual machines can use any resource from the configured pool. So basically, it's the same idea. We allocate resources to this pool, and we put virtual machines into the pool, and then the virtual machines are using the resources out of the pool, and they're sharing resources between them in the pool. It's helpful when moving virtual machines. Resource pools can be used for chargeback. What does that mean? So if we were creating a cloud. Okay, so don't forget what we're doing is really creating a private cloud. But if we have lots of different customers, so let's say I was the ICT for TAFE SA and I've got IT studies, I've got hair and beauty, and I've got building and finishing, all these different departments, I might just actually enable a resource pool so I can give them the allocation of resources and they're not interfering with anyone else. And also, based on the allocation, I can actually present a report, say, hey, we provided you this much service. And if we were actually not just a whole entity and we had to transfer basically payment within the departments, then we can actually use it for charging the various departments for their use of the resources or their allocated resources. Some of the resource pool types are processor, memory, Ethernet, and virtual hard disk. So same sort of resource areas that we've already spoken about. And obviously resource pools can be configured through PowerShell as well, such as these ones. And storage and networking. So like I said, we're going through a whole heap of these, but in the next couple of weeks, we're going to look at some of these a little bit more closely. So demystify storage appliances. So I don't think I think we should all have a good idea about storage or shared storage. What is a storage appliance? It's basically a computer with a 64 or 32-bit processor. It's got memory, it's got network adapters, and it's got storage host bus adapters. So basically the things that connect the hard drives or the drives to it. So basically it's a computer. You got the front end and you got the back end. The front end is what you see, and the back end is what's actually happening. So in the back, you've got multiple physical interfaces where you're connecting hard drives, SSDs, etc., but they're presented as lungs. You might have heard that term before. And these lungs are logical units, and behind the scenes, they might be simple lungs, they might be mirrored, or they might include parity like RAID 5. And in the back end, you might be connected to a whole bunch of disks. You might have heard of the term JBODs. So JBODs is just a bunch of disks. It's a chassis where you just chuck in a whole heap of disks and then you're connecting to it in the back end. And all these hard drives can be mirrored. Some of them could be hot spares, but wherever that configuration is, it doesn't matter. At the front, it's presented as iSCSI or fiber channel over Ethernet, NFS or SMB. So as far as your Hyper-V host or even vSphere ESXi host, they are connecting to this, and at the back it's doing all of that. So I think with our TrueNAS, you sort of got an idea of what this is doing. But obviously TrueNAS is very simplified, and in a in a Microsoft solution, if you remember from Set4, we can actually turn our server into a SAN. We can actually create iSCSI interfaces, and obviously if we had the hardware, we could create the fiber channel or fiber channel over Ethernet interfaces so that other devices or servers can connect to our Microsoft server and utilize the disk underneath. So we can cluster them together. So this is you can deploy 2 or more for what's called a scale out solution. So scale out, if you remember, I think we discussed this in class before. We've got the scale up and the scale out, and basically scale out means instead of having one big server, you can have multiple smaller servers, but obviously they will work in cluster. And then you have various servers. These could be all different Hyper-V servers, and obviously they could be using Ethernet, gigabit, 10 gigabit, or fiber channel to connect via these protocols: iSCSI, fiber channel over Ethernet, NFS, or SMB. And obviously the beauty of it is that the virtual machines are running on these servers, but the storage of the virtual machines are on this shared storage. So we can do things like live migration, which is like vMotion, and we can switch the execution from one server to another server very quickly without moving where the hard drives or virtual hard drives are stored. We can do failover cluster, or which is high availability in VMware, by storing the virtual machines on the shared storage. If one server fails, those virtual machines running on this server can be restarted on another server because it still has access to the stored virtual hard disks. So if you were doing this with Windows Server, you would use the Windows Server Spaces feature to do all of these things. But obviously you can actually, the Windows Server file server can be used to present these types of interfaces to these servers. Okay. All right. We can also, there's a thing called cluster in a box. This is actually a physical server enclosure, and you have a whole heap of so it's like two physical servers, but they're inside the same physical enclosure. You got CPU, you got storage controllers, we've got SAS expanders, and same over here. And basically these are in the same box, and they're connected to a JBOD like I mentioned. So let me just show you maybe what a JBOD looks like. Bear with me a second. So if we look at images, JBOD is just an enclosure like this. Okay, enclosure, you put all these disks in there, and then basically here's another JBOD. So you can expand it to as big as you want, and then you have this the server or the controller connecting to them and using them. So with this cluster in a box, it's just a way of actually doing it. So availability, at least one node and storage is always available despite failure or replacement of any components. So if you look at this, if any one of this fails, it's almost like mirroring servers. Simplicity is pre-wired, so all these connections are pre-wired inside. You don't have to do anything. It's already set up like that. Flexibility, so the PCI Express slots for flexible LAN options, external SAS ports for JBOD expansion, and you could just use their office level power, cooling, and acoustic. So really, what is this? This is good for a small environment, and it's like a solution just basically put into a small environment, and then it services them the client easily. So it's very it's for a small environment, like I said, and it's basically don't require specialized server room or server level power. You know, it's quiet enough that it's not disruptive. So here's an example of a physical hardware. So it's effectively two servers in the same box, and then you have a whole bunch of disks, and then you can actually put more by connecting to the JBODs if you need to. So familiar enterprise capability, so traditional storage. So this is what we've been talking about in vSphere. We've got fiber channel, iSCSI storage array. So we've got storage tiering. So if you remember, we spoke about how we've got different types of storage like SSD, hard drive, archiving, and then cloud. And we can use the the, the software to actually move data around from one tier to another depending on how much is being used. We've got the idea of data deduplication. I think we spoke about this as well. So this is where it looks for data which is exactly the same at the bit level, and just instead of storing multiple copies, it just stores it once and references it. There's RAID resilience groups. So basically RAID, redundant array of independent disks, where you got redundant hard drives. Pooling of disks, so where we can combine the space of many disks. High availability, yeah, basically means that the data is more valuable than not. Persistent write-back cache, copy offload, which is another feature which means that you do not have to involve the CPU for copying, the copying process. And snapshots, so this is snapshots referring to snapshotting of the storage rather than of the virtual machine. So all that is what we've been talking about with VMware vSphere, and it's still being used, even though it says traditional storage. It's still being used. It's very much being used, but this obviously these slides is a bit of a promotion on Microsoft and their solutions. So this is traditional. This is what everyone else is using, probably what most vSphere people are using. But we can do the same thing with Microsoft Server and with storage spaces. So we still got storage tiering. We can have data deduplication, and we've got flexible resilience, pooling of this, high availability, all the same things with storage spaces. So it's not saying this is old, this is new. It just means that whatever we used to do with hardware and various different vendors, now we can actually do with software with Microsoft Server. To be honest, which is better? Depends. It's six of each, half a dozen of the other. It's basically depends on what your expertise is. If you're a Windows solution, your Windows a Microsoft company, then file storage, server storage cluster with storage spaces is something that might be easy for you. If you're not, then this traditional storage just means you have to deal with different vendors, different software, and integrate it together. Whereas if you're fully Microsoft, this integrates with other Microsoft services quite easily. But to be honest, if we look at the previous these these interfaces, these standards are not Microsoft specific, meaning that even though this is a Microsoft solution, it doesn't mean if it presents itself as a fiber channel or fiber channel or Ethernet or iSCSI, it doesn't mean that we can't use it from our vSphere virtualization platform as well. But to be honest, it doesn't make too much sense to do that because we would be paying for the software license for Windows Server. Whereas if we use a traditional storage option, we would be buying this hardware from, let's say, HP. It will come with its proprietary software or management interfaces. We would just set up the things like we did with the TrueNAS, and then we would integrate it with our vSphere platform, but we wouldn't have to pay for the additional Windows licensing. But you could mix and match. So like I mentioned before, the storage tiering, you have different types of storage, and you have what's called hot data and cold data. And the software the management software will move data back and forth between the different storages, and it's just showing two, but there could be more. And basically, the more it's being used, the higher it can be. It moves it to the faster storage, so the hot data. The less it's being used, it becomes cold and it moves it to slower storage or cheaper storage. So basically, this is almost like a hybrid drive. If you remember what a hybrid drive is, where you have some solid state part, some mechanical hard disk part, and you're sort of getting performance from the solid state hard drive, but you're sort of saving money by getting capacity with the mechanical drives. And this is something that's available with storage, tiered storage with storage spaces, but it's also available with other technologies as well. So with storage spaces, the Microsoft solution, you can have storage pools, which is a collection of the physical disks. And then we can actually create virtual disks. These are not virtual machine virtual disks, but this is a sort of combination of all the physical disks, but we can create them as virtual disks from this physical thing, and then we can use storage spaces features to actually present them to the servers. Storage spaces features resilience, integrity on standard disk. It can integrate with continuous available and CSV integration. Clustered shared volume. That's what CSV stands for, if you're wondering. So basically, the storage is clustered across multiple servers. Optimal storage for storage tiering and multi-tenancy isolation. When you say multi-tenancy, it means that the people using this hardware or the services could be from different departments, different companies, and because of that, you can isolate the data so there's no interaction between the data. Data deduplication, we mentioned this before, but it basically identifies and removes duplicates within data without compromising the data integrity. Obviously, if we have a file which is 5 gigs, let's say 4 gigs, a DVD ISO, if we store that ISO in multiple places on the same physical server, let's say you stored it on your home drive, I stored it on my home drive, and someone else stored it elsewhere, let's say there's 10 of us, that's 40 gigs. But this data duplication will actually go through, recognize that these are the same files at the bit level, even if the names were different. And so usually it runs overnight. So after it identifies it, it basically removes the data and stores it once. And then you don't have to go find your data. Your data is still there. So if you go to wherever you stored it, you still can find that file, but it'll be just referencing the same data as everyone else's. And obviously, if you make a change, then that becomes different. So you'll spawn off and create a new file. So this requires NTFS file system and failover cluster and shared storage support is supported, and CSV or cluster shared volumes support is added later. So that's supported. We can significantly decrease the space for VHDs, so that's the virtual hard disks for Hyper-V virtual machines. So if you think about it, if we have multiple Windows servers, and they're clones of each other, let's say, the virtual hard disks may be very identical or might be identical. So basically this can be duplicated. But the requirements are that the VHDs or virtual hard disks must be accessible on a SMB3 network share, which is a Windows network share for applications, and the duplication of virtual machines that use the local storage is not supported. So you have to be using shared storage. So what is offload data transfer? Traditional copying, when we copy a data from one file server to another file server, our computers actually, the data is read and transferred into our memory. The data is transferred, written from memory to the SAN, and the CPU has to be involved in all of that. But what the offload means is that the server issues a read command and a write command. So in this first part, even if we're reading from one part of the SAN and writing to another part of the SAN, our computer is involved. Whereas if we're doing this, it uses a read token and a write token, and the SAN completes the data copy and confirms the configuration completion, and our computer doesn't have to be involved anymore. Benefits is its increased performance, reduced utilization, and but the SAN must support the data offload transfer. So if we think about this, basically from our interface, we're saying copy. All right, copy from here to here. So then we basically go away, and then it's gonna happen behind the scenes without involving our computer or the CPU. What is SMB3? Like I said, SMB3 is a version of the Windows sharing protocol. So SMB3 is the Microsoft sharing for applications. SMB3 is a network file sharing protocol. It's a protocol version that's backwards compatible. SMB3 is a features in Windows Server. It basically supports transparent failover, scale out, multiple channels. So multi-channels where we can communicate over multiple connections. SMB Direct or SMB over RDMA. We can also have SMB encryption, volume shadow services for SMB file shares, and we can also manage this SMB file share with PowerShell. We can only use SMB3 only if both sides supports it. Okay, so Hyper-V data files are stored on network shares, so that's a way of having shared storage. Virtual machine configuration, VHD files or checkpoints. The Hyper-V supports file sharing over SMB3 or newer, so it has to be SMB3, it can't be just normal file sharing. File server and Hyper-V server must be separate servers. They must be member of the same Active Directory domain. And basically running the virtual machine data files can be deduplicated for VDI. So basically, if you don't know what VDI is, that's virtual desktop interface infrastructure, sorry. That's where instead of having a full desktop computer, you can have a thin client, you can connect to a virtualized version of your desktop, and that's on the virtualization environment. And obviously, all those desktops will be clones of a master, golden master of the desktops, and then obviously they will be very similar, if not identical, and they can be deduplicated. SMB has reliability and availability and performance as a SAN, and benefits is its easy provisioning and management, and uses existing infrastructure, so it's very familiar.